Hey class, I'm going to work through this problem to help us work through some of these two sample t-tests. So the problem I'm going to work on is on page 499 in our textbook, exercise 13.89. It says, a restaurant located in an office building decides to adopt a new strategy for attracting customers to the restaurant. Every week it advertises in the city newspaper. To assess how the advertising is working, the restaurant owner recorded the weekly gross sales for the 15 weeks after the campaign began and the 15 gross weeks for the 24 and the weekly gross sales for the 24 weeks immediately prior to the campaign. Alright, so it's some sort of advertising campaign, and then they went and figured out the weekly sales for the weeks before and the weeks after, 15 weeks after, 24 weeks before, and he wants to test, finally, can the restaurateur conclude that the advertising campaign is successful? Alright, so we got this data here, before and after. So here's the 15 weeks before, and here's the, during 15 weeks during, 15 weeks after the campaign began, okay, and the 24 weeks before the campaign. Okay, got it. So let's first set up what our null and alternative hypothesis should be. So something like the mean of during should equal the mean of before. All right, which we know we can rewrite this to something like mu of d. This is pretty ugly. Minus the mu of m is equal to 0. Okay. And then our alternative, what they want to prove is that, that during the campaign their sales were higher, right? So that's what they want to prove. So remember, whatever it is we want to prove, that belongs in the alternative hypothesis. That means, whatever. That way it makes the alternative hypothesis the burden of proof on the alternative hypothesis. Remember, the null hypothesis, there's no burden of proof. It's already assumed right. So again, we can rewrite this. ud minus um is greater than 0. Right? So ud would be bigger. Okay, so this is a one-tailed test, right? One-tailed test. How do we know it's a one-tailed test? Whoops. Whoa. Because we just have a greater than here. If this was not equal to, if we just want to know that it was different, then we would put a two-tailed test, right? All right, and then up above it says use a 5% significance level. All right, so we say alpha equals 0.05. All right, so what the notes say and what we've been doing in class is we first have to determine which of the tests that we can do. We have to ask ourselves, is this paired data? Is there some reason why this observation is related to this observation? Well, in this case, no. Like, these are completely separate times. These are all come from the same restaurant, right? So it could be, and again, these are different weeks and all kinds of stuff. But it could be, again, this one might be a little tricky because it says this is over time, right, before and after. But they're all from the same place. If this was a different question that said, like, here's one restaurant's sales during, and here's their restaurants before, and then here's a different restaurant during, and then that same different restaurants before, and here's an even third restaurant during and a third before. Well, that would be paired data, right? But in this case, it's not paired data. This is all from the same restaurant. It just has different weeks, right? So each one of these represents the gross sales of 1 week. Here's 15 weeks. Here's 1 week, afterwards, right? So it's not paired. So we don't have to worry about paired data. So then we have to figure out whether we should use assume that the variances are equal or not. So how do we do that? We first have to run an f-test, right, to determine whether or not the variances are equal here. So this is pretty easy. We go to data, data analysis, f-test to sample for variances. Click on OK. We get this little drop-up box. Click on the first one here for our first sample, and highlight the during. Hit enter. Variable 2 range. All of that. So it's okay that our samples are different sizes. We have to include all the data. So we don't want to cut off this data down here. It's alright that the samples are different sizes. That's okay. I did include labels. Alpha 0.05. I'm going to put the output range, right there. There we go. And click OK. Alright, so we're getting some statistics out of this. Here's our during and here's our before. So this is the average, right? Average sales. So we can see that the average sales do seem bigger than before. So that helps us out later on when we're sort of looking at this. Our variance, this is what we care about for this f-test, right? The f-test just tells us whether or not the variances are equal. And here's the 167,000, it's a pretty big variance, and 194,000 variance, right? And remember the null hypothesis for this f-test, the null hypothesis is that the variances are equal. So we can only reject that null hypothesis if the p-value is very low. So in this case, here's our p-value. It is not very low, right? 0.39 is not low. By low, I mean it has to be lower than 0.05. Right? That's going to be like the alpha level that we'll use for this f-test. We have alpha right here. So in this case, we can say, no, we can't reject this null. We can't reject that null hypothesis. And so we assume that the variances are equal. Great. So all that does, all this f-test, is tell us which t-test we should use in order to answer this original question way up here. Right? So this does not give us the answer to this question. It just gives us the answer to which test we should use. Right? So now we know we should use equal variance. We have to assume equal variance because we can't reject the null of this sort of subtest. This null of the subtest is the null hypothesis, is that the variances are equal. Okay, so we go into data analysis, and now we're going to use the t-test to sample assuming equal variance. If this number, if our f-test number was really low, like 0.05, lower than 0.05, like 0.01 or something, then we would assume unequal variances. But this is an equal variance problem, so click on OK. And the only difference here is the math behind the scenes is a little bit different as far as assuming what the standard deviation of the difference between the two means is. All right, so here's our variable 1. So this is just like before. Variable 1 range, hit enter. Variable 2 range, all that, hit enter. Hypothesized mean difference. Well, that just comes from our null hypothesis. It won't let me go see, but it's 0, right? Remember we decided that the difference between these two should be 0. There should be no difference. The null hypothesis says that there should be no difference between these two. Okay. There is labels, alpha 0.05. I'm gonna click on this output range, and click in here, and I'm gonna say I want it right here. And that's it. Right? Nothing else. Done. Okay. Scroll down here. Alright, so again, we get our mean before, during, and before. Here's our variance again, a number of observations. So it's a good idea to sort of eyeball these and say, yep, there's the 15 weeks before, during, and here's the 24 weeks before. Make sure that we are collecting all our data. That's a good sort of check. So this is, because we have equal variance, is also called a pooled variance problem. So this is a pooled variance, essentially just to have some math to figure out what these two variances combine with pooled. Hypothesized mean difference. Here's our degrees of freedom, which is just this guy plus this one minus 2, which is helpful because we have to have a degrees of freedom to figure out whether or not this t statistic is significant or not. So here's the t statistic, right? So just like when we did last week, when we figure out how to actually calculate a t statistic for a one sample t-test, this just goes and does it for us. There's a formula behind it. It's in the book, and there's some videos on it on YouTube if you want to figure out what the actual formula is. It gets a little cumbersome. It's not simple. And it's easy enough for Excel to just give it to us. All right, and then we get two p-values, right? And we have to go back. We were actually concerned about a one-tail test, right? So here's the p-value for the one-tail test. But we always get both of them. And it's not a terrible idea to just look at them both. But here's the one-tail t-test. So we got 0.005. Right? So remember, our rule is if the p-value is lower than alpha, then we reject the null. So if the p is lower than alpha, we reject the null. So our alpha was 0.05. Here it is. P-value was 0.005, which is smaller than 0.05. So we reject the null. Right? So here's the null. We say, well, there's not any proof that this. There's enough evidence to say that this might not be right. In fact, there's enough evidence to say that this might be the case. So this is good if you're the advertising agency, right? If you're the newspaper, and say, well, look, there's actually some statistical proof that by running an ad, your sales will go up. All right, so that's it. That's all there is to this. Not much. So these other guys in here, these critical T's, we didn't talk about these in class. It's another way of actually figuring out how to do this. A critical t is actually just what the actual value is at your alpha level. Right? So if we say I want an alpha of 0.05, then it will go and figure out, well, if I had exactly 0.05, what would the t be? It's sort of like this norm inverse thing. Remember when sometimes I said, what's the 5th percentile of some inverse? This is doing the same thing. What's the 5th percentile in terms of t's? And that's what this critical t is. So it depends on what you put in as your alpha. So again, it's another way to solve this problem. The p-value way is just as easy, but this says that if your t, our t is 2.64, is bigger than the critical t, then you would reject the null. It's the same thing as this sort of p-value thing. So that's why we didn't learn it. Sort of redundant in the same way of thinking about it. But these critical t's are just based off of the distribution. This is our real t. This is the t that our observation said, right? All right, so that's it. Hopefully that was helpful. Thanks.